Hello, this is Charles Shapiro, soil scientist specializing in crop nutrition from the University of Nebraska. Today I'm going to be talking about the quest for the Holy Grail of soybean production. What I mean by the quest for the Holy Grail of soybean production is kind of a tongue-in-cheek phrase for searching after improved yields and making that the focus of our production management system. There are many products and ideas out there that people have been putting forward over the last few years that would help somebody reach 100 bushel, 150 bushel soybean production. I'm just going to concentrate on the crop nutrition part of that and talk mostly about what we know. Our University of Nebraska recommendations are really primarily soil supply based, and we put a lot of emphasis on pre-season applications. Recently, over the last few years, there's been increased emphasis on using micronutrients to fine-tune the production system, and many of those micronutrients are put on mid-season through the irrigation system or with a ground rig. So we'll cover that as well. The University of Nebraska has two NEB guides that cover our basic recommendations for fertility on soybean. In front of you on the screen is our fertilizer recommendations for soybeans and the use and management of micronutrient fertilizers. The link for them is also on the screen, but it may be just as easy to search for those titles. In those two publications, we cover a lot more information about fertility for soybeans than I can cover in a few minutes today. We recommend that our fertility program be based on soil sampling and testing, and that the basic nitrogen, phosphorus, potassium, soil pH be at the recommended levels before we would worry at all about micronutrients. So you have the University of Nebraska recommendations for phosphorus for soybeans, and just keep in mind here that the critical level for Nebraska on soybeans is 12 parts per million Bray. When we talk about the demonstration areas that we're going to be looking at in our field days, this will be an important number to consider. The same thing holds true for potassium. In Nebraska, our critical level is 125, and so any soils that are below that would get a potassium recommendation. Both the phosphorus and the potassium recommendations have been developed over the last 30 or 40 years. And we feel pretty confident that they are as good today as they were when they were promoted in the past. We continually do research to determine if these are still adequate, and we have changed them over time. So we feel like in our high-yield environments today, these numbers are valid. When we think about foliar fertilization, most of the soil scientists in the Midwest feel like there needs to be some sort of indication that there's a problem before we would recommend using a micronutrient or an in-season application of nutrients. In front of you, you see a table that's taken from Penn State University, but this table or one similar could be found at a lot of university land-grant websites. I'm showing you both the corn and soybean numbers just to show that corn has similar situation as soybeans. A couple of things to note. One is that it's very important that we know what stage we're sampling from. The crop in the corn here, it says silking stage. In the soybeans, it says prior or early to flowering. And it's also extremely important to know what part of the plant we are sampling from. These numbers that are on this table are very hard to come by, and as the plant ages or even different parts of the plant, the analysis is going to come out with different numbers. The other thing to note is in many of the nutrients, there's a range of values, which means that we aren't really sure what the actual number is. And sometimes that range is fairly large. If you look at the part per million for iron in soybeans, it ranges from 50 to 350. So that indicates that it's very hard to diagnose a micronutrient deficiency, especially if you don't have any symptoms or any other evidence that you have a problem. And this is going to play out time and time again as we try to determine if foliar fertilization is necessary. Another way to look at the fact that this is a difficult area to document improvement in yields is when we look at the estimates of micronutrients uptake by the crops. If you focus on the middle column there for a 60 bushel soybean crop, you'll see that very little material is getting into the soybean plant. The highest of the micronutrients, iron, there is 1.7 pounds per acre, but something like molybdenum is only at 0.01 pound per acre. So it doesn't take a lot of these nutrients to be sufficient for the crop. And many of our soils, especially here in Nebraska, are fairly young soils. They have a lot of organic matter, and they are well supplied with these micronutrients. Last year at the Soybean Management Field Days, we had a nutrition experiment at the 4 sites. In front of you, you have the treatments that were applied compared to a control. You can see that the control yielded about 65 bushels, which is fairly good yield given the diversity of the 4 sites. The range of yields was fairly minor, with the best yielding treatment at around 67 bushels. So we only increased yield about 3 bushels, and it may be difficult to prove that the increase was significant. If we look at the data more closely, we can see some things that may be hard to explain. The foliar application of nutrients, and these were a mixture of various nutrients, so it wasn't one nutrient by itself, rather it had combinations of micronutrients. But there was a big difference between putting on the nutrients at V4 compared to R2, and I can't really explain why we did so much better with the R2. If you look at that bottom line where we had starter and the foliar V4, that was almost as good as the foliar R2. They were both 67 plus bushels. So based on this, where we saw a little bit of improvement with our foliar mixtures mid-season, we designed for 2012 a little bit more in-depth study focusing on foliar application. The sites that we have for 2012 are spread across Nebraska. Platte Center and David City are both in the east, Lexington is to the west, and O'Neill is in the north central. We use our normal University of Nebraska recommendations and examine each of these soils. We'll see that for the most part they're very fertile and very well supplied with nutrients. The things that would jump out at me looking at these soil analysis is, first, the pH at O'Neill is 5.3. We would prefer to see soils at 6.0 or above for most of our soybean production. So at O'Neill, they have a pH problem. The organic matter is fairly high at all the sites, especially O'Neill, which tends to have sandier soils. At 2.7 is a fairly high number. Nitrates, I should point out, for a 0 to 8 sample, the range there between 15 and 23 is fairly high. I would think that the reason it was high was because through the fall and spring we had warmer than normal temperatures, so maybe there was more mineralization of the organic matter. But normally it would be in the 3 to 5 part per million range, or maybe a little higher. Phosphorus levels, if you look at that Malick 3P, all of them are above our 12 critical level. At David City, it's 16, and there maybe we would put some phosphorus down just to keep it above the 12, but we would not expect a yield increase for certainly Platte Center or Lexington. And then phosphorus, the same way, all of those numbers are above 125. So these sites are very well supplied with nutrients. Generally, the soybean management field days find cooperators that are very proactive in maintaining their fields, and so we usually aren't on depleted soils. So with that in mind, our demonstrations this year may not show too much of a difference in yields. The fertility treatments that we chose for 2012 are a combination of what we learned from the previous year and then some input that we received from the soybean board members. In front of you, you have a table with 14 treatments horizontally, and each of those X's indicate that the label on the top of the column was applied to that treatment. I'm going to go through these treatments individually. or in small groups so that you understand what we are doing out in the field. Unfortunately, I don't have the yields now, but in the winter we can add the yields to this information. The first 6 treatments are ones that we have put together based on our experience last year, where we had some improvement. You might recall 2 or 3 bushels with a combination of either starter N or some mid-season application of fertilizers. So the first column is 25 pounds of N put on at the R4 stage. The second column is N-Rage, which is a mixture of nitrogen, phosphorus, potassium, manganese, and the nitrogen part of it is a triazone N, which is a slower releasing N. The Soy Grow is a mixture of iron, magnesium, manganese, and zinc. So those 2 products together would apply pretty much all the micronutrients a crop might need, but the N-Rage has more N, and so the Soy Grow alone would just be the micronutrients. So treatments 1 through 6 are various combinations with the omission of 1 or, in one case, 2 of those nutrients. So hopefully we can pick out which of those is the most effective. Treatment 7 is a control where we have not applied any further materials. Treatment 8 through 11 are additions of commonly found nutrient materials: poultry manure, ammonium sulfate, MAP, potash, and lime. The poultry manure we put on at 3 tons an acre, and that had quite a bit of nutrients in it, over 270 pounds of nitrogen, 230 pounds of phosphate, and 180 pounds of potash, plus 48 pounds of sulfur and some zinc as well. The other ones had much less nutrients. The ammonium sulfate had about 21 pounds of N and 24 pounds of sulfur, and the MAP, which is 1152O, had 16 pounds of N and 78 pounds of P2O5. So those treatments as a group really had a fair amount of nutrients. Then that treatment 12 there is what some people call the kitchen sink. That had everything on it, all the different treatments together. At 2 of the sites, at O'Neill we put on lime, and then in Lexington there was another product called Soy Green applied. We're going to change gears a little bit here and focus on where and when to sample soybeans for foliar analysis. When I went out to sample these fields, I went out and met some colleagues at one of the sites, and just kind of by accident I asked each of them how they would sample the soybean field. And if you read the literature, it says the uppermost fully developed trifoliate. And if you look at the diagram in front of you, where the arrow points to B, you see a very nice example of a trifoliate. However, if you look on the left, either C or D arrows, those trifoliates are a lot darker green. So the question is, which of those leaves would you sample? A, I think, is obviously not fully developed, so that's probably not a good answer. B is not fully developed in terms of color, but the leaves aren't touching. And C or D are about the same color. From a physiological point of view, the soybean leaf is actually a trifoliate leaf. There are 3 leaflets that make up the leaf. So the next question is, do you take just the green leaves, or do you take that petiole, which is the connecting tissue between the 3 little leaflets and the stem? And we had a little bit of discussion out in the field on whether to take the petiole or not take the petiole, whether C or D would be the appropriate leaf to sample. I don't really know what the right answer is. From talking with a lot of my colleagues, probably C or D would be the best answer. But there was some difference in whether to take the petiole or not. The main point here, and the reason I'm bringing this up, is that if 5 or 6 of the so-called experts don't know how to sample, it's probably unlikely that if you just sent somebody out to sample a soybean field for you, you would get a sample that was appropriate. The point here is that sampling becomes critical if we're going to be comparing whatever we get from the lab to a known set of values. The other point here in the slide is what stage of growth are you going to sample? Here we have flowering. You can see the white flower on the pictures, but some people recommend sampling when pods are beginning to develop. And so one has to record not only what leaf one samples from, but the stage of growth, because it could affect how you interpret those numbers. Regardless of whether my sampling was the best or not, I did conduct sampling all the sites, although at 2 of the sites I was able to get a complete set of the treatments for the R2 and starter treatments. The other 2 sites had not had anything applied at R2, so I did not take samples there. If we look at this table in depth, and the first 2 lines of this table show the averages for the site, and then the lines below that show the individual treatments. This is the average of the 2 sites. There wasn't too much difference between the 2 sites. And then the final bottom line where it says critical value, those numbers I took from that table I showed you earlier from Penn State that listed critical values for flowering. So if we go through this, I'm going to spend a little bit of time going through the detail because I think it's instructive of what you will find in many soybean fields. First of all, if we look at the comparison between David City and Platte Center, most of those numbers are pretty close to each other. I don't have an LSD or anything, but the magnitude difference is fairly minor. They're not that far apart geographically, maybe 40, 50 miles. And then if we look below that at the average of those treatments, again, they are pretty consistent. There's very few places where there would be more than a 10% difference. So let's look at the critical value for each column and see if we can find any kind of deficiency showing up. The nitrogen and phosphorus and potassium from the soil tests I already told you was fairly high, and the leaf samples indicate this. The critical value of 5% N, the average in the plants was 5.7. Critical value of phosphorus was 0.4%, average in the plant was 0.62%. Potassium, same kind of relationship. So for the 3 major nutrients, we were way higher than what is considered the minimum. For sulfur, we were just about right on. If we look at that calcium number, it's a range of 0.35 to 2. That's a fairly good size range, and our samples fell pretty much in the middle. The magnesium is towards the low end, but really a sufficiency range, you should be in good shape at the bottom as well as the top of the sufficiency range. For zinc, we're at the top of the range, and manganese, also we're kind of in the middle. Iron, we're pretty close. The only nutrient, copper, is the only one that is close to the bottom. That is right at 10, but none of the samples went below 10. So there's no real evidence here that we have a micronutrient deficiency. Now, some people would say you can't base your action on one sampling and that one would want to sample 3 or 4 times through the season. And that may be a good strategy, but there is a certain cost to sampling in terms of time, labor, and analysis costs. And so if that is going to be undertaken 3 or 4 times a season, that goes into the amount of soybeans you need to get back if you do apply treatments. The one situation where we do recommend foliar analysis is when you have a problem in the field and you have a good and bad area and you have eliminated possibilities of other management or pest practices that would cause that, then it might be useful to sample from a good and a bad area. When you're doing that, you're comparing one sample to another and you're not actually using the critical values. However, one caution there is that when you throw one nutrient off in a plant, it's likely that other nutrients would be off, and it becomes difficult to determine which is the causal nutrient. For instance, if the P is low, it might mean that the zinc is low, or the zinc might be too high. So it's very hard to isolate one nutrient at a time when you have a problem like that. I'm going to sum up with just a basic review of our recommendations for fertility in soybeans. Really, a program to manage your nutrients has to be based on soil tests. We think that a good sampling every 3 or 4 years is better than trying to cover too many acres every year. In other words, I'd rather a sample come from 20 acres every 4 years than 80 acres every year. That way you can identify where issues may be. If you grid sample, that would be even better. Try to maintain your pH above 6. That helps bring micronutrients into solution, and the extremes of pH work the other way. Soil P and K levels should be based on university recommendations. If you over-fertilize, you are just spending extra money without the potential to improve your yields. If you are interested in experimenting with leaf analysis or micronutrients, we prefer you to have some basis for thinking there is a problem. So a leaf analysis would be critical if you want to try using some of these micros. Again, on a troubleshooting basis, you can sample from known good areas and known poor areas, and that might help you identify problems. All in all, start with a soil test, use recommendations that are based on research, and you should be in excellent shape in terms of your soybean fertility.